And I'm Mason.
And we're from the Adams family.
Our team is our family. Karen, our mom, Colin, our dad. I'm Mason.
I'm Nora.
In our presentation, we'll be going over how we're fulfilling our challenge. Challenge 3, Moon Race, Ready, Set, Launch. Our innovation, key lunar activities, Earth business plan, and how we are solving a crucial issue that humanity is facing.
How are we fulfilling the challenge? In space, we're going to be designing a crewed habitat on the lunar missions, using algae as a radiation filter for the habitats. Algae is also an oxygen producer for the habitat, and it creates biomass which we can use as a protein source and fuel. On Earth, we're going to help reduce carbon emissions and save the world.
What space tech are we learning from and innovating? So, NASA and Airbus developed a photobioreactor, which was on board the ISS, with the goal of filtering CO2 to O2. It was small scale, but successful. Another experiment on board the ISS, well, actually outside the ISS, leaving multiple dormant types of algae outside the ISS for 450 days. They were exposed to extreme conditions, like radiation, temperature changes, but they survived. And these two types began to grow once they returned to Earth.
Our innovation is Biowalls. So these are walls filled with algae. They have multiple purposes. These include shielding astronauts from radiation. This uses algae that's most efficient for radiation shielding. And it also emits O2 as a waste product from photosynthesis, so we can use that for our habitat.
But how do the biowalls work? Well, they're plastic rolls with integrated tubing filled with water and algae. It takes CO2 using a compressor and using light and CO2 to photosynthesize, and it turns it into O2 and biomass. Using computers to monitor CO2 and O2 and biomass levels, and then a filter allows biomass to be removed and water pumped back into the system.
Why algae? Algae uses photoremediation to neutralize radiation. It converts CO2 to O2 more efficiently than plants or trees. It produces biomass as a waste product that can be used as a protein source, fuel source, and a raw material in manufacturing. It's resilient and can live in harsh climates, takes up very little space in transport, and can be reconstituted.
So, what's our plan? On the moon, our first steps include choosing plastics, pumps, and manufacturers. We'll hopefully use some bioplastics, and we're going to narrow down the strains of algae by how much oxygen they released and their radiation resistance.
How are we going to test the algae? So we're going to send a small payload satellites into high orbits with bioreactors. Each one will have a different type of algae. Some of our options include cyanobacteria, no-stock SP, and others from the Arctic and deep ocean. We're going to test for radiation resistancy. Each small payload will include a Geiger counter, transceiver, CO2 compressor, and O2 release.
Next, we'll send the algae we picked to the ISS for approximately a 6-month period, and we'll send it back to Earth for a DNA analysis. We'll see if any mutations occurred, and we'll just be sending the algae, not the prototype.
We will also send it to ActnSpace. This gives humans a chance to test the system. It also gives us a chance to develop a maintenance system and test the computer systems. ActnSpace is a Mars habitat simulation on Earth.
Finally, we're going to run some computer simulations to determine a good flow of CO2 to maintain in a healthy colony in a low gravity environment, determine the biomass output, and determine a really good cleaning schedule.
Fabrication and shipping to the moon. So we're going to transport it to the moon in pieces. We'll bring a small colony of algae and grow it into a larger one there. And then we'll begin maintenance schedules.
So, what's our Earth business plan? How are we going to make money to finance the one in space? So, we're going to work in the carbon offset market using walls, or biowalls. So, we're going to rent space and put our biowalls on them, on highway sound walls, apartment buildings, office buildings, and industrial complexes.
Our value proposition is to enter the cap and trade market, or carbon offset auctions. So algae converts CO2 to O2 because it's a plant. Every ton of CO2 taken from the atmosphere is worth 1 credit, or $17 US. Businesses have a cap on how much CO2 they can produce and must purchase credits for every ton after that limit. That is where we come in. We provide the credits. So people will buy credits, and then we'll use the biowalls as a carbon offset. And these markets are all over the world.
So what are our revenue streams? We own, run, and maintain the biowalls. We monitor CO2 and remove it from the atmosphere. We sell credits in the cap and trade market through brokers, and we also sell biomass. So businesses also can rent biowalls from us to put them on their businesses to lower their carbon footprint. And we maintain them. And we deal with the removal of biomass and installation.
So what are some uses of this biomass? It can be sold as a fertilizer, animal feed, protein supplement, cosmetic add-ins, eco shoe base, bioplastic, and biofuel.
What are our early business steps? First, we need to get some investors. So we could get this through Kickstarter, angel investors, and advertising on social media. We would need some money for a warehouse, prototypes, beginning construction, and advertising.
What's the estimated cost to build one wall? So taking these things into account, maintenance, compressors, plastics, algae, manufacturing costs, installation, power, and the battery, we think that the cost to make one wall that is 3 by 2 meters would be around $700.
So who are we working with? Who are our key partners? So carbon offset markets are both national and international. And there are large manufacturers who we hope to work with, both here and abroad. Municipalities who we hope to rent space from, and developers who could integrate algae biowalls into their development. We also hope to work with governments.
Customer relationships and segments. So who are some of our customers going to be? CEOs of manufacturing companies, municipalities and larger governments, carbon offset brokers. Our segments include manufacturing, environmental controls, public and private.
Carbon offsets. Why are biowalls better? So most carbon offsets are trees, about 70%, but it's incredibly hard to track how many tons of CO2 are removed from the atmosphere by trees. With algae, we can track exactly how much CO2 are removed from the atmosphere in real time. And we do know that algae is more efficient at removing CO2 from the atmosphere than trees. So for each kilo of dry algae grown, it removes 1.83 kilos of CO2 from the air. Or for each acre of algae agriculture, it removed 2.7 tons of CO2 from the air a day. The same space of trees, takes a year to do remove the same amount of CO2 from the air.
Timeline to save the world. So first we need to choose which algae we're going to use. So which one can take the most CO2 and turn it into O2? We need to find the best way to feed CO2 to the algae. So is a compressor going to work, or can we use a more passive system with semi-permeable membranes? So we need to choose our building materials, what kind of plastics we're going to use. Bioplastics would be our #1 choice. And then we need to find heating requirements for colder locations, or power for the compressor if that's the route we go with. So we are thinking that powering everything, we would like to use solar.
How are we solving a crucial issue for humanity? Well, climate change is one of the biggest issues facing humanity right now, and Biowalls has a solution and a market to sell in with multiple revenue streams.
So what are some more uses that we can sell this to other than the cap and trade market? So cities with really dense population and heavy smog would be prime candidates. Some examples are Tokyo, Beijing, and Wuhan. These people can line their apartment buildings and their highway sound barriers with biowalls. Many citizens suffer from lung diseases, and governments know that action is needed. This also opens the door for more readily available biofuels. Algae creates a lot of waste, and these would be a great way to start using biofuel more often.
Algae,
It's the obvious choice.